Good morning. I'm going to make a video, several videos, to walk us all through the SPSS assignments for this class. I'm going to start with week 3 t-tests, and if you have any questions, please email me and I'll make another video if I need to. Some of you are getting a little bit nervous at this point in the course. I know there's a great deal of reading, but I'd like you all to take a deep breath, and I'll walk you through the essential parts of the book and essential parts of the assignments. There's a lot to wade through, so let's get going with t-tests. So this is the assignment that's coming up here on the screen, and let me go into the SPSS software. So I opened up my SPSS software, and I opened up the week 3 t-test assignment. Okay, so what I'm doing here, let me close this out and start again. Okay, so once I have this up and you have this up on your screen, I want you to go to Analyze up here. Okay, I want you to go to Compare Means and a 1 sample t-test. Alright, when you go there, this is the window that comes up. Now, a t-test, you have to compare 2 sets of data. A t-test compares the mean of 2 sample data. So imagine like 2 test scores, 2 sets of test scores. Let's say it's, spelling test scores between one classroom and another, and or it could be any test score. It could be math test scores, or if you're doing an experimental group, you want to see number of sneezes before a remedy and number of sneezes after the remedy. So if you put them in a column like you see here on this screen, the t-test, what it'll do is it'll take that column that you specify and it'll calculate the mean, and then compare the mean of the other column that you selected, and it'll tell you if the difference between the 2 means is significant. Now we're going to be talking about the word significant over and over again. So let's get started. Now in the 1 sample t-test, you might be asking, well, if I'm putting in weight, for example, we're putting in weight over to the right where it says test variable. So what are we comparing it to? Now here where it says test value, I want you to put in the value 278. So in the assignment, this was going to be the norm score. What this means is that this is the larger set of the population. That's the norm. That's like the average within the population. So you're going to be comparing your sample group weight to the larger population. So those are the 2 things that you're comparing it to. You already have a calculated means of 278 for the population. You're putting that in, and you're comparing your sample to that. Okay, so once you get this going, hit OK, and you get this table. All right, now for the assignment, I'd like you to cut and paste this table and put it into a Word document, and then talk about it. Now, if you're talking about assumptions, part of the assignment is for you to discuss assumptions and were any of these guys violated. For a t-test to work and work well, there are several things that you need to consider. Now, they may be present here, they may not be, and I'll be flexible on how I grade this, because sometimes it's subjective, and it's subjected to interpretation. So one of the things that you have to look at is that the data have to be continuous. Continuous, by definition, is any data that can be, let's say, subdivided. There's some confusion as to what continuous data is and ordinal data is, but continuous data, you can subdivide it. Like, for example, if I say I'm looking at people's weight. Well, weight doesn't go on forever. There's a limit, right? I mean, even the heaviest person isn't going to be more than, 300 pounds. So it doesn't go on forever, so it can't be continuous, right? Well, the definition of continuous isn't necessarily that it goes on forever. It could be subdivided, and there's standardized measures. So if I say somebody's 300 pounds, the standardized measure is pound. Can I subdivide pound? Can I have a half a pound, quarter pound, a tenth of a pound? You can. And then one of the subdivisions is, ounces. How many ounces are in a pound? So if I say I'm 300 pounds, but my sister is half my weight, can we calculate it accurately? What's half of 300? What's 150? And it's standardized, and if I say half, you know that it's continuous. And if you come up with an answer with half, you do that with a foot. A foot is subdivided into inches. So if I say, this person is, his trophy is 1 foot tall, and I say, well, this other trophy is 1/12 the size of that ruler, of that trophy, you know that it's 1 inch. Ordinal data, you can't do that with. If ordinal data is like somebody's opinion on a scale of 1 to 5, what's your opinion of, that sports team? And let's say they have a 5. His friend has an opinion of 1 or 2, let's say. So, but can you calculate it down and say that the second person's opinion is 40% of the other? No, you can't. You can't calculate it that way. Or you can make an argument that you can, but typically most scientists will say no, that's not a standardized measure. So that would make it ordinal. So for t-tests, it needs to be continuous data. So if we're looking at somebody's weight, okay, now in the norm and in the sample, we're talking about weight. Is weight continuous? Well, if we're talking about pounds or any other standardized measure of weight, yes, it is continuous. You can subdivide that. Okay, are these, the way these were collected, the data was collected, it was a random. We're going to assume that it was, okay? And are these data independent from one another? Yes. We can make that assumption that they're independent. That means like completely different classrooms, completely different sets of people. Are they related? If they were related, let's say they had the same teacher, or they were both in the same community, we would say that they're not independent. But we're going to assume that the sample weight is not 100% related to the entire population. They don't have really anything in common, so we're going to call them independent. Okay, so and then another thing that you want to consider is homogeneity of variance. You want to know if the difference within the mean of the sample is among all the scores of the sample are not too different from each other. If they're way too different from each other, you can say there's no homogeneity of the variance. They vary way too much, so that's a poor sample. So you can run a test to determine if they are somewhat similar before you go on. And if they're somewhat similar, then you can move on and interpret the data. Okay, so let's look at this table. On the one sample t-test right here, there's a couple things I just want you to look at really fast. So we want to know if it is significant or not. Now, for our purpose now, and I'll repeat it several times later on with the other assignments, we're looking at this one here, this number here, the significance of the two-tail bell curve. Okay, let's look at this number here. We need to set up a threshold where we can say this number is significant to in terms of how it can generalize to the entire population. In psychology and in education, the threshold is 0.05. And if you can imagine a bell curve, the two extremes, one on the right, one on the left, combined, we can set it at 0.05. That means if it falls in the middle, that means it was the difference was probably because of chance alone. So we need to set the threshold out so that if the number is outside of the realm of occurring by chance alone, we need to say that the difference is significant. It was caused by something else. This number doesn't really exist in the general population. So suffice it to say that this number that I'm pointing at now, if it's less than 0.05, we say that the difference between the two things that are measuring are indeed significant. Okay, and that's important. We're moving on in this course. You're going to hear me say that a million times. So for the for the way I ask you guys to interpret these tables, look at that significance of two-tailed, and just tell me if it's more than 0.05, the difference is not statistically different. If it's less than 0.05, it is statistically significant. So look at that number, 0.014. It is statistically different. It is less than 0.05. So for your interpretation of this, that's all you need to say. Okay, so let me stop this, and that'll satisfy the requirement for the first part of this assignment.